Okay, so our last video I posted was your hints video. This video is going to go through the remainder of the problems that I haven't shown you already. So you'll be getting this Monday night. You've had 4 days to look over the study guide, so now you can match and see if your answers match mine. We already did one together in the hints video, so let's look at number 2. Again, our rule for finding domain is to set the denominator equal to 0. 5k squared minus 13k minus 6 equals 0. In order to solve for k, because this is quadratic, we are going to factor it. Two numbers that multiply to 6 are 2 and 3. If I put a 2 here and a 3 here, make them both negative, my inner will be negative 2k, my outer will be negative 15k. Actually, this is going to be positive. So we're going to have a positive 2k and a negative 15k, which will give us negative 13k. So we're good. My next step now is to set each factor equal to 0. So I'm going to have 5k plus 2 equals 0, and k minus 3 equals 0. In order to solve our first factor, subtract 2. So we have 5k equals negative 2. Divide by 5. K equals negative 2/5. If you put negative 0.4, that's okay as well. Here we're going to add 3. So we have k equals 3. So our domain, all real numbers, x cannot equal negative 2/5 or 3. Let me fix this. This is negative 2/5 or 3. Okay, so now let's look at number 3. Again, let's first look at our asymptotes. Our vertical asymptote is here, and we have another one here. X equals 1 and x equals negative 2. So what we get must match this when we factor out and solve our denominator for 0. So we have x squared plus x. Again, we just look at the denominator for the domain. Minus 2 equals 0. In order to solve this, because this is a quadratic trinomial, we are going to factor. X, 2, and 1. But our 2 is going to be positive and our 1 is going to be negative. Now we set each of these factors equal to 0. X plus 1 equals 0, x plus 2 equals 0. Add 1 to both sides. Our first matches our first asymptote. And that matches our second asymptote. So our domain, all real numbers, x cannot equal 1, negative 2. Move on to number 4. We are going to set our denominator equal to 0. So you can either solve by factoring or you can solve by square roots. I'll show you both. You solve by square roots. Add 4 to both sides. X squared equals 4. Take the square root of both sides and you're left with x equals plus or minus 2. If you factor that, you would get x plus 2 and x minus 2. And again, x plus 2 equals 0, you get x equals negative 2. X minus 2 equals 0, you get x equals 2, which is exactly what we got here. So if you solve either way, it's still correct. Your domain is then all real numbers. X cannot equal plus or minus 2. Okay, number 5. Again, we're going to, in this case, there's only one vertical asymptote. Horrible line. This right here is a horizontal asymptote. All we care about for finding the domain is our vertical asymptote, though. X equals negative 4. So let's see if when we solve this, that's what we get. Again, we set the denominator equal to 0. This is just linear, so we can solve by one-step equations. Plus 4. Negative x equals 4. Divide by negative 1. X equals negative 4, which matches what we got as our vertical asymptote. Our domain is then all real numbers. X cannot equal negative 4. We're done. Moving on to number 6, our first step is to set our denominator equal to 0. In order to solve this, we have a quadratic trinomial, therefore we will factor. 3x and x. We're going to have 2 and 5. Our 2 goes here, 5 goes here. Because if we do inner, we get 5x. Outer, we get 6x, which gets to 11x. Now we're going to set each factor equal to 0. 3x plus 5 equals 0. X plus 2 equals 0. We get to subtract 2 from both sides. X equals negative 2. Subtract 5. 3x equals negative 5. Divide by 3. X equals negative 5/3. Our domain is then all real numbers. X cannot equal negative 2 or negative 5/3. We're done. All right, since this is pretty repetitive, I'm just going to continue walking through. Again, highlight our asymptotes. Label our asymptotes. X equals 2. X equals negative 3. Set our denominator equal to 0. Okay, this is a quadratic trinomial. Therefore, we are going to, every time, we're going to solve by factoring. X is going to be 2 and 3. 3 is going to be positive, 2 is going to be negative. Now we're going to set x plus 3 equals 0. X minus 2 equal to 0, so we get x equals negative 3. X equals 2, which matches what we got before. Our domain, all real numbers, x cannot equal negative 3 or 2. Again, set denominator equal to 0. We can add 50 to both sides. This is linear, so we can just solve it normally. Negative 10x equals 50. Divide by negative 10. X equals negative 5. So therefore, our domain is all real numbers, but x cannot equal negative 5. Number 9, we're going to start by highlighting our vertical asymptotes. And now we're going to label them. X equals 3, it looks like, and x equals negative 3. Set our denominator equal to 0. Again, there's two ways we can solve this one. You can either solve it by factoring, and you will have 2x minus 6 and 2x plus 6. And when you set those each equal to 0, you get 3 and negative 3. If we solve it the other way, you can solve by square roots. So if you have 4x minus 36 equals 0, and you add 36 to both sides, you get 4x squared equals 36. We can then divide by 4. So we get x squared equals 9. Then take the square root of both sides, and you get x equals plus or minus 3. So no matter which way you solved, if you did either of these ways on a test, your answer would be right. Our domain, all real numbers, x cannot equal plus or minus 3. Let's look at our last domain question. We are going to set it equal to 0 for denominator. And now factor. 2x, x. It's going to be 7 and 5. We're going to have a 7 over here and a 5 over here. Inner gives us 5x. Outer gives us 14x. That will get us 19 as long as they're both negative. Negative 5 minus 14 gives you negative 19. And negative times a negative gives a positive. So now we're going to set each equal to 0. Do the first one, add 5. Divide by 2 now. X equals 5 halves. And if we do x minus 7 equals 0, plus 7 on both sides, x equals 7. Our domain, x cannot equal 5 halves or 7. And if you're getting to a certain point and we're matching, but you're not done, so say you get here, and you haven't finished the problem, pause the video, try to finish on your own, and then see if we match. Okay, so now we're going to be simplifying. We already did the first question together, so we're going to move on to number 12. We can factor out a 4x from the top, so we're left with x minus 2. And from the bottom, we can factor out a 4x squared, so we're left with x minus 1. I'm sorry. X minus 1, because we had 8x cubed. We can cross off the 4s. We could also take an x from each. So if we took 1 from there, there'd be 1 left. And we're left with x minus 2 over x times 2x minus 1. We then have to distribute this x back in. So we get x minus 2 over 2x squared minus x. And that's our final, most simplified version. Okay, let's look at number 13. The numerator is already factored for us, so we can just rewrite it. The denominator we can factor ourselves. 8 times 4 is 32. If the 8 is negative and the 4 is positive, that will get us a negative 4. We can cross off p plus 4. We're left with 1 over p minus 8, and we're done. That one was nice and easy. Number 14, we can factor the numerator. Oops, I'm sorry. 2x, x. 2 and 5 multiplied to 10, so that's the factor we're going to use. There's going to be a 2 here and a 5 here. Inner 5x, outer 4x. So to get to a negative 1, our 5x has to be negative and our 4 has to be positive. Now we can factor the denominator. We're going to have 7x times x, 2 and 1, because 1x, 14x will give us 15x. They both have to be positive. Now watch. We can cancel out an x minus 2 and an x minus 2. And our solution is 2x minus 5 over 7x plus 1, and we're done. Number 15, we can factor the numerator, x plus 4, x minus 4. Be careful of these quadratic binomials. The two numbers that multiply to the c term have to be the same, and the two numbers that multiply to the a term have to be the same as well. Now we can factor the denominator as well. We're going to use 5 and 4. We're going to have a 4 here and a 5 here. 5x and 12x will give us 17x, but they both have to be negative. Now we can cancel out x minus 4, x minus 4. We're left with x plus 4 over 3x minus 5. And we're done. Okay, number 16, we can factor the numerator. You're going to have x plus 3 times x minus 2 all over x plus 9 times x minus 2, because 9 times negative 2 is negative 18. 9x minus 2x gives us 7x. Look at that. We can cancel those away. We're left with x plus 3 over x plus 9. We're done. Okay, 2 more sections to go. Let's look at our multiplying section. We already did number 17. Therefore, let's move on to 18. We are going to first look at our first fraction, so this piece, and factor everything out that we can. So let's factor the numerator. 2 and 1 are going to be our numbers. We're going to have a 2 here and a 1 here, because 2x and 3x, 3 minus 2, will get us 1. So therefore the 3 has to be positive and the 2 has to be negative. All over x plus 2 times x plus 1. We're going to factor the denominator like normal. 2 times 1 is 2. 2 plus 1 is 3. X plus 2 cannot simplify, and 5x cannot simplify. That's part of this second fraction. Let's cancel everything out if we can. X plus 1, x plus 1, x plus 2, x plus 2. We're left with 3x minus 2 over 5x. And we're done. Number 19, let's first look at this first fraction. We can factor out a 2x as a GCF, and we're left with x minus 6. When we factor out the denominator, x minus 6, x minus 1. Negative 6 times negative 1 is 6. Negative 6 minus 1 is negative 7. Looking at our second part, we can factor out a 3 as a GCF. We're left with x minus 1. And 2x in the denominator doesn't factor or simplify. So let's cross off everything that's the same. And again, you can only cross something off if you see it on the numerator and the denominator. If you see 2x and 2x in the numerator, it doesn't cancel. 2x, 2x in the denominator, it doesn't cancel. Your answer is just 3. All that's left is this 3. Number 20. So looking at this just from the get-go, you can see that none of these numerators or none of these denominators are going to cancel. Therefore, we can just move right into the step of multiplying across. 1 times 3 is 3. Now we're going to do x minus 4 times x plus 8. And we're going to distribute x times x times 8, negative 4 times x, negative 4 times 8. So we have 3 over x squared plus 8x minus 4x minus 32. Now we can simplify that. So we have 3 over x squared plus 4x minus 32. We just combined these. And that's your answer. Number 21 in the numerator. Looking at our first fraction, we can factor the numerator, x minus 5, x plus 5. Our denominator, we can factor out as 3x squared as our GCF. We're left with x plus 7. Okay. Oh, sorry. So we're done factoring our first fraction. Now we can factor our second fraction. We can take a GCF of 3x out. So we're left with x minus 9 over x plus 5. So all we do is pull out a 3x from this whole entire piece, and we'll write what we're left with. We can cross off x plus 5, 3 and 3. We can also cross off the x and let there be 1 left, and now multiply across. So we're going to have x minus 5 times x minus 9 all over, don't forget about this x that's left, times x plus 7. Now we can continue simplifying. We're going to have x squared minus 9x minus 5x plus 45 over x squared plus 7x. We just distributed. We're not done because we have to combine these terms. So we're left with x squared minus 14x plus 45 all over x squared plus 7x, and we're done. Something that I was seeing a lot is people thought they can just cancel out these x squareds now, or cancel them from the get-go. You cannot, because this is technically one whole term, and this is one whole term. You can't take pieces out of each term. You can only cancel out entire terms. Okay, so this question says the length of a rectangle is 3 over y plus 8m, while its width is 6 over ym. Find an expression for its area. Area equals length times width. In order to find this area, they gave us our length, they gave us our width, so let's just multiply them together. 3 over y plus 8 times 6 over y. Nothing simplifies, so let's just multiply across. 6 times 3 is 18. Y times y plus 8. We're going to distribute this y into each term within the parentheses. So we have 18 over y squared plus 8y. M squared is the unit of measure. We're done. Okay, so last but not least, we are going to work through the rest of the dividing rational functions questions. Number 24 is where we are starting. Our first step is to always multiply by the reciprocal. So we're going to keep the first fraction. Change the sign to multiplication. And flip the second fraction. So a little helpful hint, if you want to write this at the top of your study guide, keep, for dividing only, keep, change, flip. So now let's start factoring. We can factor out this numerator, 5x, x, 3 and 9, we're going to have the 3 here, 9 here, they're both going to be positive. Inner gives us 9x, outer gives us 15x, which adds to 24x. Now we can factor out a 2 from the denominator, so we're left with 5x plus 9. From the second fraction, we can factor out a 4, so we're left with x plus 4. And the denominator, we can factor out a 2, so we're left with x plus 4. Now let's cross everything away that we can. 5x plus 9, 5x plus 9, x plus 4, x plus 4. 2 times 2 is 4. So really, they both cancel out because 4 over 4 is 1. And all that we are left with as your answer is x plus 3. Number 25, we are first going to keep the first fraction. Change the sign, flip the second fraction. Keep, change, flip. Now let's factor everything. 4k squared cannot be factored. The denominator, though, you can pull out of 4k, and you're left with k plus 9. This also can be factored. K, k. 4 times 9 is 36. It also adds to 13. Down here, we can pull out a 5k, and we're left with k plus 4. Now let's cross away everything that we can. K plus 4, K plus 4, K plus 9, K plus 9, 4, 4, K, 1K left over. But then we still have a K here, and we have 5K here. We can cross off those Ks as well, and we're left with just 1/5. All that left was that 5 in that denominator. So again, I crossed off 4s. I took a k from each, so we still had k up here. So we had k over 5k. K over 5k, the k's will still cancel out, so then you're left with 1/5, which is what we had. Just to reiterate that part, because I know that was a little bit confusing, or may have seemed the way I explained it. Okay? So now for number 26, keep, change signs, flip the fraction. (15r squared minus 18r), we can factor out a 3r, so we're left with r minus 6. 4r cannot be simplified. Again, here, we can factor out a 3r, and we'll have r minus 6. If you want, you can just go ahead and cross these away first, because we know those are the same. But if you want to take a step further, that's okay too. These are still going to all cancel out, and you're left with 4r over 7 as your answer. Okay, 4 more. Let's look at number 27. We keep the first fraction. Change the sign. Flip the second fraction. Our first fraction, 6b squared, cannot be factored, so we can just rewrite it. Our denominator, however, we can factor out a 6b squared, and we're left with b plus 1. The numerator does factor b, 2, 3. Oh, no, I'm sorry. This will not work, because even if you have -2, -3, a negative times a negative is not a negative. So we're going to fix that, and it's going to be 6 and 1, with the 6 being negative and the 1 being positive. Now we can also factor out this denominator. It's going to be 7 and 4, both positive. And we're done. So now let's cross off everything that's the same. So we're left with b minus 6 over b plus 4 times b plus 7. We still have to multiply all of this across. So your final answer when you multiply the denominator is b squared plus 11b plus 28. And we're done. Looking at number 28, again, our first step, keep first fraction, change the sign, switch and flip the second fraction. Looking at our numerator of our first fraction, we can factor out a 2, and we would be left with 5k minus 9. In our denominator, we can factor out an 8, and we would be left with 5k minus 9. 6 minus k doesn't simplify. In our denominator of our second fraction, we can factor out a 9k squared. We would be left with k minus 6. Crossing away everything that we can. 5k minus 9, 5k minus 9. 2 over 8 will become 1/4. And now, kind of like what we talked about last week. So we have 6 minus k and k minus 6. These do not mean the same thing. So let's multiply. Let's pull out a -1 from this so that we get -6 plus k. And now these mean the same thing, so we can cross these away. We still have a negative 1 on top. So everything that we're going to multiply is negative 1. This crosses away. Negative 1 times 1 is negative 1. 4 times 9k squared would be 36k squared. And you're done. So if you see two numbers, so 6 minus k and k minus 6, that looks really similar. So think, I can factor out a negative 1 from one of those in order to get them to cancel out. But don't forget to account for that negative 1. So we still included that in our solution. And then again, we multiplied across everything that was left, the 4 and the 9k squared. Two more. We're going to keep change flip. Times. Ooh, I didn't flip it. We can factor out our numerator of our first fraction, 5n. n. We're going to use 10 and 6, 10 here, 6 here, 6n and 50n. This will have to be negative, the 50, and the 6 will have to be positive to get to negative 44. In the denominator, we can factor out a 5n squared, which will leave us with 7n plus 8. Now, factoring out the numerator of our second fraction, we're going to use 9 and 8, because 9 times 8 is 72. We're going to have the 9 here and the 8 here. 8n and 63n will give us 71. They're both going to be positive. Now our denominator, we can stay the same. Now let's cross everything off. 5n plus 6, 5n plus 6, 7n plus 8, 7n plus 8. We're left with n minus 10 times n plus 9 all over 5n squared. We're not done. We have to do our last step. Multiply across with the numerator. N squared minus n minus 90 is what you'll get in the end. Divided by 5n squared, and we're done. Last but not least, we will keep our first fraction. Change our sign and flip our last fraction. Now let's factor everything. We can factor our numerator of our first fraction, 3x and x. And we're going to be using 10 and 9. Our 9 is going to go here, 10 is going to go here. 10x, 27x. In order to get to negative 37, they both have to be negative. When we factor out our denominator, we have 5x and x. We're going to be using 2 and 3. So we have 2x and 15x. To get to a negative 13, the 15 has to be negative and the 2 has to be positive. Now, for our second fraction, we can factor out a 7, and we're left with 5x plus 2. In our denominator, we can not factor anything out, so we're just going to leave it as 3x minus 10. Cross away our 3x minus 10s, our 5x plus 2s, and we are left with 7 times x minus 9 over x minus 3, which simplifies to 7x minus 63 over x minus 3. Because we distributed our 7 into both terms. And we are done. Good luck on your test, guys. Yeah.